The astronomical basis of the calendar. All calendars rely on astronomical cycles, but these cycles are not consistent in duration and cannot be accurately predicted over very long periods of time. This means that calendars are not entirely reliable, and even direct observations made to maintain accuracy can be subject to error. To address this, calendars are usually based on rules that aim to provide a close approximation of astronomical cycles over a given period. Day. It is observed from the surface of the Earth that the Sun appears on the eastern horizon and disappears below the western horizon. The occurrence of day and night is due to the Earth's rotation on its axis in a direction from west to east when viewed from above the North Pole. The duration of a day depends on the point of reference used to measure a complete rotation. Day's length according to the Sun. As seen from the Earth's surface, the sky appears to form a dome-like hemisphere where all celestial objects, including the Sun, Moon, planets, and stars, move across. Throughout the day, an observer would witness the Sun's ascent during the morning and descent during the afternoon, reaching its highest point at local noon. At this point, in the northern hemisphere, the Sun's shadows are at their shortest and point precisely towards true north. Recording the length of day based on the Sun's movements is known as an apparent solar day. However, timing two successive occasions where the shadows are shortest would rarely result in exactly 24 hours due to a difference in length between the shortest and longest apparent solar day, which can be as much as 16 minutes. Apparent solar time is a measure of the Earth's rotation relative to the Sun. However, in the modern world, it would be challenging to adapt our lives around a constantly changing day length. Instead, our clocks and watches keep a mean time based on the length of an average apparent solar day over the year, known as the mean solar day, which lasts 24 hours. The length of the apparent solar day changes from day to day due to a couple of factors. Firstly, the Earth's orbit around the Sun is an ellipse rather than a perfect circle, which means that the distance between the Earth and the Sun varies throughout the year. For example, in January, the Earth is closest to the Sun, whereas in July, it is furthest away. Secondly, the Earth rotates around an axis that is tilted, causing the height of the Sun in the sky to change over the year. In summer, the Sun is higher in the sky at local noon, while in winter, it is lower. These two factors work together to alter the apparent speed of the Sun as it moves across the sky at different times of the year, ultimately affecting the length of the day. The day length according to the star. We observe that stars behave similarly to the Sun during the day on a clear night. They ascend from the eastern horizon and move across the sky until they set somewhere in the west. Every star will eventually reach its highest point in the sky as it crosses the local meridian. Astronomers use a transit instrument to record the exact moment that a star transits the local meridian. This instrument is a telescope that is stationary and can only point at a narrow strip of sky that aligns with the local meridian. The telescope can be adjusted in altitude and aimed at any star that becomes briefly visible in the narrow field of view. The time between two successive transits of a star is the duration of a day measured by the stars. It is the length of time it takes for the Earth to rotate and bring the star back to the same position in the sky it occupied on the previous night. This is known as the sidereal day, which lasts just over 23 hours and 56 minutes. Since the sidereal day is shorter than 24 hours, the stars rise 4 minutes earlier every night according to our watches. This is why we observe different constellations in the night sky at different times of the year. Months. The Earth's natural satellite, the Moon, completes one orbit around our planet in a month. As it moves in its orbit, it changes its position relative to the Sun, which affects the portion of its face that is visible to an observer on the Earth's surface. This phenomenon results in the different phases of the Moon. When the Moon is closest to the Sun in the sky, none of its illuminated sides is visible to us, making it a new moon. We can only see it if there's a solar eclipse, which is a rare event when part or all of the moon's disk moves in front of the sun. As the moon moves farther away from the sun, a small sliver of its illuminated face becomes visible, creating a waxing crescent moon. This phase is usually seen in the western horizon just after sunset, and it sets relatively quickly. As the moon continues in its orbit, it moves even further away from the sun, illuminating a larger fraction of its Earth-facing side, which sets later. By the seventh day, the moon is in the first quarter, so called because it has completed 1/4 of its orbit, though it appears like a half-moon. When the moon completes half of its orbit, it's opposite the sun in the sky, and its entire illuminated side is visible to us. This is called a full moon, and it rises at sunset and sets at sunrise, so it's visible throughout the night. The waning moon looks like it's shrinking because it's getting closer to the sun. A golden quarter moon rises around midnight and stays high in the sky until the next morning. Contrary to popular belief, the moon is not just visible at night. The synodic month, which is the time between one new moon and the next, is approximately 29.5 days and is based on the moon's phases. Years. The regular cycle of 4 seasons, spring, summer, autumn, and winter, is experienced by people living at mid and high latitudes. In contrast, at low latitudes, in the tropics, the temperature remains relatively constant, and there are distinct wet and dry seasons. The progression of the seasons was integral to ancient people in finding or growing food and would have spurred them on to determine the lengths of the year and the seasons. One of the ways this problem was tackled was by observing the position of the sun and how its position shifts in the sky throughout the seasons. There is considerable archaeological evidence that this was undertaken independently by numerous cultures worldwide in prehistoric times. The seasons. Exploring the cause of the seasons requires understanding the Earth's rotation axis, which is tilted at an angle of 23.5 degrees from the vertical, known as obliquity. As the Earth orbits around the sun throughout the year, the sun's rays hit first one pole and then the other, resulting in the seasons, as depicted in the animation below. June 21st marks the summer solstice, during which the north pole of the Earth tilts most towards the sun. This causes the sun to be directly overhead at latitude 23.5 degrees north, the Tropic of Cancer, at local noon. This day is often called Midsummer's Day, despite being considered by astronomers as the start of summer, as it is the longest day of the year. The northern hemisphere experiences warmer temperatures in summer than in winter because the sun's rays are more concentrated when they strike the Earth and because the sun is above the horizon for a longer period. Conversely, during this time, those in the southern hemisphere experience midwinter because the south pole is tilted furthest away from the sun. By about September 22nd, the Earth orbits anticlockwise and reaches the autumn equinox, signifying the start of autumn. Currently, neither pole is tilted towards the sun, and the sun is directly overhead at the equator, latitude 0 degrees, at local noon. All places on Earth experience equal amounts of daylight and night, hence the term equinox, which means equal nights. Only during the autumn and spring equinoxes does the sun rise due east and set due west. On December 21st, the Earth experiences the winter solstice, during which the North Pole is tilted furthest away from the sun, and it is now overhead at local noon at latitude 23.5 degrees south, the Tropic of Capricorn. This marks the shortest day of the year, with the sun rising to its lowest altitude above the horizon for northern hemisphere observers. Astronomers consider this as the beginning of winter, but it is often referred to as Midwinter's Day. Since the sun's rays are more spread out and the sun is above the horizon for only a shorter duration in winter, it is colder. During this time, people in the southern hemisphere experience summer when it is winter in the northern hemisphere. Spring begins on the vernal equinox, which occurs around March 21st. As with the autumn equinox, daylight and night are of equal length everywhere, and the sun is directly overhead at the equator at local noon. The number of daylight hours changes throughout the year, with the UK experiencing more daylight hours in summer than in winter. However, the number of hours of daylight and darkness we experience each day varies depending on latitude. At the equator, days and nights are equally long throughout the year. Conversely, for those living at the North Pole, the sun is above the horizon for half the year during the Northern Hemisphere summer but never rises during the Northern Hemisphere winter. This is the opposite at the South Pole, where day and night last around 6 months each. For latitudes between the equator and the poles, the difference between daylight hours and darkness at midsummer and midwinter increases as latitude increases. Sun's journey through the sky. The path of the sun through the sky varies throughout the year due to the Earth's tilt, and this path is known as the ecliptic. The celestial equator, the equivalent of Earth's equator, is where the ecliptic intersects, and it is where the equinoxes are located on the celestial sphere. During the spring equinox, the sun moves northward along the ecliptic, crossing the celestial equator as summer approaches for northern observers. In contrast, during the winter equinox, the sun moves southward across the celestial equator, resulting in a lower position in the sky for northern observers and a higher position for southern observers who are anticipating their summer. Calendars have historically been developed based on the duration of one cycle of the seasons. The tropical year, which is defined as the time between two successive vernal equinoxes, is commonly used in modern astronomy. The term tropical comes from the Greek word tropo, meaning to turn, referring to the sun's movement from south to north and back again during the year of the seasons. Although the calculation methods may differ, all methods agree that the current length of the year of the seasons is 365.242 civil days, rounded to 3 decimal places. The sidereal year, which is the time taken for the Earth to complete one orbit with respect to the fixed stars, was equal to 365.2564 mean solar days in 2000. Over the course of a year, an observer can see every constellation of stars visible from their latitude due to the sidereal year. The figure below illustrates how the sidereal year works. In the Northern Hemisphere summer, the North Pole is lit by the sun, and an observer on Earth can see only stars in direction 3, such as the zodiacal constellation Scorpius, because the stars in direction 1 are on the day side and hence not visible. 6 months later, during the Northern Hemisphere winter, stars in direction 1, e.g. the zodiacal constellation Taurus, become visible in the night sky, while stars in direction 3 are only up during daylight hours. The stars in direction 2, e.g., Leo, are visible in spring, while those in direction 4, e.g., Pisces, are visible in autumn. Alternatively, we can think of the sidereal day, the day length measured according to how the Earth rotates in relation to the stars, which is shorter than 24 hours, meaning the stars rise 4 minutes earlier each night according to our watches. Over 30 days, the stars rise 120 minutes or 2 hours earlier, and over 12 by 30 days, the stars rise 24 hours earlier. Several ancient civilizations, including the Egyptians, Babylonians, and Greeks, have used sidereal, star, calendars based on the constellation's slow progress across the sky over the year.